Okay, we are at section 17.3, boundary effects, reflection and transmission. We're going to start with reflection. Let's share the PowerPoint, make sure, let's see. Yeah, that's what we did last time. So if you have a pulse, coming, and notice that there's like a beam or something, it's a rigid beam. If you have an incident pulse coming at the rigid beam, when it hits the rigid beam and bounces off, it's gonna be reflected. It's going to reverse directions, uh, and it's going to be where it's a positive going pulse um, to the left. When it returns, it's a reflected pulse. It's downward. Now, if you were to have a loose end, let's say a loose ring on a pole. Sorry about the dogs barking. I don't know what. There's probably some cats outside or something. Uh, you have an incident pulse. The incident pulse, it'll allow the ring will allow that pulse to raise up and then come down, and so the reflected pulse is the same as the incident pulse. It's positive going. So if it's anchored, the reflected pulse is negative. If it's loose, the reflected pulse will be positive. Um, Now the if you have a if you have a, a case where you have a low density string and a high density string, uh, there's a boundary there. The incident pulse goes, and uh, it continues on in the heavier string, but it's inverted at that boundary. Even though there's no ring or there's no pole, there is a transition, so it's reflected negatively. The reflected pulse is inverted, and the non-inverted transmitted pulse moves along the heavier string. So at that transition point, you have both transmission and uh, reflection. Uh, okay, now from the if you're going from a large density to low density, uh, a heavy string to a light string, you have an incident pulse. The reflected pulse is not transmitted, and the transmitted pulse moves on at the lighter string. Um, so the it's kind of similar to the going to the heavier string is almost like having a hard, because it's higher density, it's having a hard reflection, whereas if going from heavy to light, it's like a loose reflection, um, and you can think of it that way. Uh, the velocity of uh, the string, the velocity of the pulse is the square root of the tension in the string divided by the linear mass density, the mass density of the string. Okay, and I think that ends that section. We're going to do boundary conditions on the next one.